Good morning, guys. In this lesson, we'll learn the chapter number 1.1, the unit, different types of numbers. There are a few times or many types of the numbers. Let's start with natural numbers. There, if like as you see, this first of all number and definition and example. Okay, so it's mathematical definition, and this one is example with the examples. If you don't understand, you can check with examples. If definition is more difficult for you, you will check with the examples. So number, the first type of the number is natural number. What is the natural number? Let's read first of all the definition of natural number, and after that we'll check with the example. Uh, any whole number from 1 to infinity. Any whole number. Uh, Very, how can I say, important whole number, and from 1 to infinity. Like, let's to show you. Where's my pad? Okay, so its initial value is 1, starting in 1 to positive infinity. Okay, so from 1 to infinity, it's, for example, 1, 2, 3, 4, 5, blah blah blah. Is a more important, I said it, whole number. We need whole number, 1.5 or 1 over 2. 0.5 is not natural numbers. Okay, and 1.5 is also not natural number. 5 point is in fraction form, 3 over 2. So that's why the first of all we need whole number, and after that positive values. And the second types of numbers is odd number, a whole number that cannot be divided exactly by 2. As you see, the first 1, the second 3, 5, 7, also whole number, and it's positive odd numbers. Okay, maybe here you can add it, positive odd numbers, and a but is exactly not cannot divided by 2. For example, 1 over 2 is, the answer is 0.5, is not, how can I say, natural number or integers. That's why the odd numbers must be 1, 3, 5, 7, and the next one is 9 exactly, 11, 13, and 15, blah, blah, blah. And even numbers, the opposite or inverse of odd numbers, even numbers, also a whole number that can be divided exactly by 2. The opposite definition of odd number, and a whole number that can be divided by exactly 2. So 2 over 2 is 1. 4 over 2 is 2. If you're looking, how can I say, the answer is exactly integer. Okay, so 2 over 2 is 1, 4 over 2 is a 2, and a 6 over 2 is 3. And for example, 18 over 2 is exactly 9. The answer is integer, positive integer. That's why the even number. I'm so sorry, it's not even number. 9 is because of odd number is 9, and that's why even number is at 10. After 9 and before 9 is 8, and 10 is exactly 9. An integer, maybe for all these definition before, we should explain the integer because it's really important, and look carefully. Integer, as you know, is any of the negative and positive whole numbers, including also 0. Minus 16 is negative even numbers, and plus 17 is positive odd numbers. So these, what is the difference of the other numbers? As integer is not, how can I say, like you cannot write it in decimal form or fraction form. Okay, Only you can write it integer -3, -1, 0 is also including, and a 2 and 3, maybe 1005, and maybe 25,342, blah, blah, blah. And prime numbers, a whole number greater than 1 which has only two factors, the number itself and 1. As a smaller prime numbers is a 2, is the initial value is of prime numbers is 2, and after that is 3. 3 is cannot divide it by 2. The answer must be, how can I say, not decimal form, and 3 over 2 is 1.5. And just it should be divided only two factors. The first one is 1 and itself. 2 over 1 is 2, and 2 over 2 is also 1. So we need, the answer must be integer. Okay, so 11, after 11, which number is prime number? 13 exactly, because 13 is just divided by 1 and itself. Okay, just a moment. Where's my mouse? Okay, it's here. So, and square number, the product obtained when an integer is multiplied by itself. Square number is 1, 4, and 9. And because of 9 is the square of 3. 3 square is 9. And for example, 49 also is square number because of the 7 square is exactly is equal to 49. And fraction form, and last one is fraction, a number representing parts of whole number and written as a common fraction in the form of 1 over 2 or a over b as a decimal using this decimal point. 1 over 2 is equal to 0.5 in a decimal form, is in a fraction form, fractional form. Okay, so exercise, there is have some exercise. Let's choose some examples. Maybe after that you can get it well done. So here's a set of numbers: the -4 and -1, 0, 1 over 2, 0.75. If you look at carefully, there's many types of numbers. For example, negative integer exactly, or negative even integer, okay, and -1. So -1 is also it's natural number. No, exactly no, because the natural is initial value is +1. It's just negative numbers, negative integers, and blah blah blah. As also we have decimal form, the fractional form. So what is the question? First one is the option A, natural numbers. Choose natural numbers from this set. So what was the natural numbers, definition of natural numbers? Let's read it again. Any whole number from 1 to infinity, sometimes called counting numbers, is exactly starting with 1, 2, 3, 4, 5, 6, 7, 8, 9, and blah, blah, blah. So just we need positive and integers, positive and integer, or starting with 3, because 0.75 is decimal number. That's why it's not natural number. So 3, 4, 6, 11, 16, 19, and 25. These numbers called natural numbers from here, okay? And even numbers, if you look carefully, even numbers, there's not written positive even numbers, just written even numbers. So we can take the negative values of from these sets. -4, even number exactly. 0, and even maybe some books written in 0 also including even number, but in university, when you go to university, maybe there you cannot see that 0 is not even number. So in a 4, exactly, positive even number. And a 6 also, positive even number. And a 16 also, but 25 is not even number. 25 is odd, positive, odd number. And integers, also we should take the negative and positive integers, okay? And square numbers is also 4 and 16 and 25. 25 is square root of 5. And odd numbers, positive odd and negative odd, you can take it. Negative odd is -1. And a positive odd number, 3 and 11 and 19 and 25, okay? If it's not divided by 2, 25 is exactly not dividing by 2. And so 25 is odd number. And fractions. And the last one, I, neither square nor prime. What does it mean? Is it not square and not prime? And square is 16, first of all, okay? And a 25 also. And a 4 is square number. And what is the prime number? It's starting with 2 and 3, exactly, and 11 and 19. And the other is the answer of I. So, and there are some also examples. If you want, you can stop the video and you can answer. And please write the comments of under the video lesson. If you write the comments, okay? Exactly, I will return it. So the next 4 odd number after 107 is a 4 after that, an odd number, exactly positive. After 107, the odd number is 109. Yes. After than 111 is not divided by 2. You cannot divide it. Okay. And third and fourth, yours, you can write the comment part. And a big one, 4 consecutive even numbers between 208 and 2008 and 2013. What does it mean consecutive? Even numbers between 2008 and 2013. Consecutive, it means, for example, between 1 and 4. What is the consecutive numbers between 1 and 4? Exactly 2 and 3, okay, are consecutive number. In Turkish, ardışık sayılar, okay, arka arkaya gelen sayılar. 1, 2, 3. But just here we need, even if we need even number, we shouldn't write 3, just 2, okay? And here also, after 2008 is exactly 2010, and blah, blah, blah. So it's, you can write the common parts, or you can write at home your paper, and please send me your answers, okay? And third, state whether the following will be odd or even. The sum of 2 odd numbers. First of all, let's look. What does mean sum? Remember that the sum is the result of an addition. The sum is, in Russian also, summa, or addition of the results of the numbers. So term is often used for any calculation in early mathematics, but its meaning is very specific and at this level. So the sum of 2 odd numbers, even or odd. For example, 2 is even number, not odd. We need odd numbers. So 3 is odd number plus 7, for example, is also odd. What is the sum of these 2 odd numbers? 10. And what types of 10? Exactly even. So odd plus odd is even. The sum of 2 even numbers, 4 plus, for example, 12, is both of them even numbers. And the result of these 2 numbers is 16. 16 is exactly even number. That's why the answer is sum of 2 even number, even plus even, exactly even. Okay, thank you. And other options, please, you can choose yourself. Okay. And the last one, it's not last one, but the, how can I say, the examples of last one is living math. There are logical questions, some questions. There are many types of numbers. Find out what these numbers are and give an example for each. For example, what is the perfect numbers? What does it mean perfect numbers? You can search with your Chrome or Google, okay? And I want to just read the definition, okay? So numbers that are the sum of their positive divisors exact methods are called numbers. Or just a moment. Okay, for example, 6 is a perfect number. Why? Because of, now I will show you, 6 is perfect number. Why? Because the positive divisors of 6 are 6, you can divide by 1 and 2 and 3. And the sum of these divisors of 6 also is equal to 6. Okay? So the sum of these divisors of 6 is also is 6. That's why the 6 is perfect numbers. If you add all its divisors exact itself, it makes 1 plus 2 plus 3 is exactly 6. And what is the second one? Palindromic numbers. And also I want to read the definition of these palindromic numbers. Are numbers whose reading direction in the same band to our reading inverse. Example, 1, 4, 8, or 99. If you read the inverse of 99, okay, 99 is exactly 99. If you read from here, is also 99, or 101 is palindromic number. When you read it from here, also in the same, and from here you can read the same. Okay, 101 and 101. And narcissistic numbers. Okay. In other words, numbers that allow themselves. For example, and okay, in this also, this option is also, you can write the my comment part. Okay, if you watch video lesson, please leave your answer, especially the exercise 4 and option C. You can write the comment part of video lesson on YouTube, exactly. Okay, and the next page, using symbols to link numbers. There are symbols of mathematics. Mathematics use numbers and symbols to write mathematical information in the shortest, clearest way possible. We have used the operation symbols plus, or positive, negative, minus, and times, or multiplication and division, divided by. Since you start school, now you will also use the symbols given and marking below the right mathematical statements. For example, let's show 19. 19 is less than 45. What does it mean less? This one is less, or this one is? 19 is less than, okay, 45. And this symbol we need right now. And 12 plus 18 is equal to 30. 12 plus 18 is equal to 30. Here's our symbol of mathematical symbol is equal to, okay, it's equal. And for example, option E also, a negative 34 is less than 2 times of minus 16. Why? Because of in negative, you know, it's number line. And first of all, we need 2 times of minus 16. Minus 16 times 2 is minus 32. Okay, 32. And where is the location of minus 34? Exactly here, approximately. Minus 34. And which one is bigger than other? And negative 32 is more than, okay, bigger than minus 34. And here, the last page of our lesson, also other examples you can check. Okay, you can leave your answers in my comments part and YouTube video lesson under the video lesson. And for example, here, say whether these mathematical statements are true or false. For example, minus 12 more than minus 4. Is it true? Is it true? Exactly not true. That because of in negative numbers, which one is less than other or more than other is the answer is inverse of answer. For example, minus 12 is exactly less than minus 4. Okay, in positive number is when write in positives, for example, plus 12 and plus 4. Which one is less than other? Exactly, 4 is less than 12. But in negative numbers is minus 12 is less than minus 4. Okay, and here also in square root of 16 is equal to 4. Exactly is true. So multiples and factors. You can think of the multiples of a number as a times table. For example, 4 is how many times of 2? Exactly 2 times of 2. And for example, the multiples of 3. 3 is how many times of 3? 3, exactly 1 times. Or 3 is how many times of 1? Exactly 3. And 6 is 3 times of 2. Okay, so here as you see, 3 is 2 times of 3. And after that, you will take 6. And 9 is 3 times 3, or 9 times 1 is 9. And here we can stop that video lesson and see you later, guys.